I'm meteorologist Ryan Davidson. I'm saying good morning to you because we are here early in the lab at the Weather Channel, and we had some questions about different types of precipitation and how hail forms. So we're going to start first with different types of winter precipitation. We're talking about snow versus sleet versus freezing rain versus regular rain. Now you take a look at this, it's kind of an indication of what the atmosphere tends to look like. Right along here you see this warm air wedge. We're going to pay attention to that as we go through. So let's take a look. First of all, we have for the cold air. If you have cold air from the top of the atmosphere all the way down to the ground, that's when we see snow. Everything stays frozen from way up high, way down to the ground. Next, we move over a little bit, we get this little intrusion of warm air. So you've got snow here, then it melts for a bit, and it turns into little pellets of ice, and then it hits the ground as sleet. Then we get a little bit further on, you get a little bit of a stronger wedge of warm air, and it stays pretty warm through most of the atmosphere, but down to the ground it's still very cold. So you have this snow that falls, and then it melts as it goes through this warmer layer, and then once it hits the ground is really cold. And what's happening here is that the cold raindrops freeze instantly on contact as it gets to the ground. Now once the air is completely warm, you have very cold air at the top of the atmosphere, and all those little snowflakes melt as they come down to the ground. They finally hit the ground as rain. So that's how different types of precipitation is formed. It's all about the thickness of the warm and cold air in the atmosphere. Freezing rain, that's what usually forms as chunks of ice on things. You get these coatings. That's what brings the trees down in central Pennsylvania in the middle of the winter. And then sleet, those are little tiny little pellets of ice. They kind of look like little styrofoam balls. That's what we see as sleet. Now let's take a look at the summer weather. We've gone from winter, we'll go to summer, we'll talk about hail. Hail is really cool. You need a little bit of ice, and you get a little bit of water, and what happens is it starts to move these tiny raindrops up into the thunderstorms, and once they get up here, they start to freeze. It gets really cold in the tops of the thunderstorms. So you get that cold raindrop and it starts to freeze. Now once it continues rising, you get more cold raindrops that stick to this, and it becomes a very large piece of hail. And then once the wind is no longer strong enough to hold that big chunk of ice up in the atmosphere, well, that's when it tends to fall to the ground. You get massive, massive chunks of hail, depending on the speed of the wind that is moving upwards. Let's take a look. Here's what you need. For a normal sized piece of hail, maybe about a quarter, 1 inch in diameter. It's not a very strong wind, but if you consider it's 50 miles an hour moving straight up, that's pretty intense. Go a little bit bigger. Let's talk about what we have. Teacup or baseball size, I believe, golf ball, 1 3/4 inches, okay? That needs a little bit more wind. That's going to need 64 mile an hour winds going straight up in the atmosphere to make that piece of hail stay up there and get that big. Even bigger, let's go baseball size hail. That's 2 3/4 inches of ice. You're going to need a really strong upwards wind, about 80 miles an hour, going straight up from the ground, straight up into the clouds to keep that piece of hail up in the clouds. And once they're so big that these upward winds can't hold them, that's when they fall to the ground. You're going to need, for a piece of hail the size of 2 grapefruits, one massive 8-inch piece of hail, you're going to need 160 to 180 mile an hour wind going straight up, an updraft, to keep that hail up in the clouds. All right, that's what we have for your types of precipitation and your hail. We'll be answering a little more questions a little bit later.
That looks really uncomfortable. What are you doing? Well, okay. Just be careful not to fall. You okay there? Dear Tim and Moby, how do snowflakes form? And are they really all different? From Lars. Let's take a look at where they form. Snowflakes are actually made up of snow crystals, or ice crystals that form inside clouds. At extremely cold temperatures, like less than -40 degrees Celsius, the water vapor inside clouds can condense directly into ice. At temperatures between 0 degrees Celsius and -40 degrees Celsius, water vapor first condenses onto dust particles, making little droplets that freeze. Well, I'm getting to that. Everyone knows that the molecular name for water is H2O. That means that one water molecule is made up of two hydrogen atoms bonded with one oxygen atom, H2O. In liquid form, water molecules bump up against each other and move all around. But when water freezes, the molecules arrange themselves into a more stable formation, the crystal lattice. The ice crystals that make up snowflakes are symmetrical because they reflect that internal order of the water molecules. Yeah. The crystal lattice is the basis for every snow crystal and snowflake out there. A snowflake's shape is determined by the conditions under which it forms. Mostly we're talking about the temperature and the humidity of the air. The colder the air temperature, the sharper the tips of the crystal will be. At warmer temperatures, ice crystals grow slower, making for more subtle shapes. Snow crystals tend to form simpler shapes when humidity is low, and more complex shapes when it's high. Well, those are the snow crystals in their purest structure. They stick together to form our snowflakes, and they continue to grow and change as they fall towards Earth. By the time a snowflake reaches the Earth's surface, plenty of elements have affected its shape. Hey, not bad. Anyway, it's pretty darn unlikely that any two snowflakes could ever look the same. They all form uniquely and have unique journeys, even though they start out with the same molecular structure. I'm sure Moby can tell us more. What are you seeing, Moby?
Have you ever felt like you need a PhD in meteorology to decipher the daily weather forecast? Like that 50% chance of rain thing? What does that mean exactly? Does it mean that it'll be raining 50% of the time today? Or that there's a 50% chance that it'll rain at some point today? Meteorologists call this number the probability of precipitation. According to the National Weather Service, this percentage is supposed to tell you the chance of precipitation occurring at any one spot in the area covered by the forecast. They define it with a mathematical formula. The probability of precipitation equals C times A. C is the meteorologist's level of confidence that precipitation will occur somewhere in the forecast area. And A is the percentage of the area that's expected to get measurable precipitation, which is defined as 0.25 of a millimeter in the United States. That's usually enough for a couple little puddles to form. If your weather person is 100% confident that 25% of the forecast area is going to get rain, that's a 25% chance of rain. But if they're 50% confident that 50% of the area is going to get rain, that's also a 25% chance of rain. This means that the more you move around, the more likely you are to run into that part of the map that has a chance of getting rain at some point. If you're still a little confused, don't feel bad. This is the official NWS definition of the probability of precipitation, but even meteorologists admit they aren't consistent about it. A 2015 survey of 188 meteorologists and broadcasters found that many people calculated probability of precipitation in slightly different ways. Different specialists had different ways of turning the outputs of their forecast models into percentages. They also varied in how they generalized from the chance of rain in one very specific spot to a wider area, and how they generalized a prediction for half a day to a more specific time. What they all had in common, though, was a lot of confidence that their answer was the right one. Bottom line, predicting the future is hard, and the probability of precipitation could be better defined by meteorologists and better understood by the public. But if the forecast says 10% chance of rain, and it rains, your meteorologist wasn't wrong. You don't need to call them and complain. It's just that with the current conditions, you happen to draw the short straw. Thanks to all of our Patreon patrons who keep these answers coming. If you want to learn more about weather science, check out our video where I explain why rain has a smell.
My name is Ralph James and I work here at the Met Office headquarters here in Exeter. And I work for the part of the Met Office called Observations. And what we do in Observations is that we gather all of the information that our forecasters would need to produce various forecasts. Behind me you will see a fairly standard Met observing enclosure, and today we're going to talk specifically about how we measure rainfall, its intensity and the amounts. And the first thing that we're going to look at is the very simplest of rainfall measuring devices, and we call it a 5-inch rain gauge. So what we have here is a 5-inch rain gauge. Very, very simple in operation. But what we have here is a very sharp edge, and the distance between the two sharp edges across the diameter here is 5 inches. You'll see that there's a funnel within. The rainfall drops into the funnel and then travels down this tube and is collected in a very, very simple glass bottle. In order to measure the rainfall, all we do is tip the rainfall into a graduated measure, like this. And then a simple process of simply looking at the amount of rainfall on the graduations there. And I'm looking at this now and I can see that since the last time this gauge was checked, we've had around about 3.2 millimetres of rain falling into this rain gauge.
Rudy Rainbow, Weather School.
May I introduce myself first? Hail is a special type of rain. You don't see me very often, since a hailstone only forms in large thunderclouds. Thunderclouds mostly form during summer. That's the time when the rays of the sun are especially strong and make many water particles rise into the sky. They create huge clouds with lots of water drops. The wind is blowing very hard in these clouds, and the drops are blown very far up. High up in the cloud, the air is very cold, and the water drops there freeze into ice. That makes them heavier, and so they start sinking again. Farther down, the ice grains hit the water drops there. They stick to the ice grains and make them grow a bit more. Once the ice grains reach the bottom of the cloud, the wind blows them back up. More water drops stick to them. This keeps on happening until the clumps of ice grow too heavy to float and fall to the ground. That's what we call hail. Some hailstones can even reach the size of a soccer ball.